Question 4. Iron forms many complexes that contain iron in the oxidation states. 2 plus and 3 plus means the iron's lost 2 electrons or it's lost 3 electrons. Hexaaqua iron 3, so we're talking about Fe3 plus, react with an excess of hydrochloric acid in a ligand substitution reaction. Well, hexaaqua means that it's FeH2O6 with 3 plus charge, an excess of hydrochloric acid. Hydrochloric acid makes Cl minus ions in a ligand substitution reaction. And you need to know that Cl minus ions, you have 4 of them around a metal atom, a metal ion in a transition metal complex. So 6 waters, Fe3 plus, because it tells you it's 3, oxidation state 3, 4 Cl minuses. Cl gains 1 electron, so it becomes a Cl minus ion from hydrochloric acid, that is, and I need 4 of them. I can only fit 4 of these around because Cl's are larger than waters, so only 4 can fit around the Fe. I know it's a minus charge, well, for 2 reasons. I've got 3 plus and 4 1 minuses, leaves a minus charge on this side. Waters that come off, the 6 waters that come off, 6 water ligands released, have no charge, so this must be a minus here because there's 1 minus on the left hand side or 1 minus on the right hand side. Another way of looking at it is that I know this is Fe3 plus, so it's in oxidation state plus 3. The Cl has gained 1 electron, so I've got 4 1 minuses. 3 plus and 4 1 minuses leave minus 1 left over. Explain why the shapes differ. So why have we got something with a coordination number of 6 ligands around it, and then a coordination number of 4, something that's probably octahedral and something that's probably tetrahedral? Why has the shape changed? Well, the coordination number or the shape has changed because only 4 Cl's can fit around the Fe ion because it's larger. Hexaaqua ions react with an excess of NH2, CH2, CH2, NH2 in a ligand substitution reaction. You need to know ligands like this are called bidentate ligands. Nitrogen has a lone pair of electrons on it, and so that can form a coordinate bond. It can act as a ligand. But on this side, this NH2 has got a coordinate bond, lone pair of electrons that can act as a coordinate bond, so it can form 2 coordinate bonds. In other words, it can take the place of 2 ligands. So one of these can replace 2 waters. In other words, those 6 waters could be replaced by 3 of these. So if I draw that as a structure, then I've got Fe with NH2, CH2, CH2, NH2, one of these around with 2, this bidentate ligand with 2 coordinate bonds here, and this one has 2 coordinate bonds, and this one has 2 coordinate bonds, and that makes 6 bonds around it. So one of these can replace 2 waters. Now I'm not quite sure where the Fe2 plus is, and so I can put a square brackets around it and put a 2 plus, because I know it's got a 2 plus charge because it's an Fe2 plus, and so there's 2 pluses on the Fe, or at least on this complex ion. I'm not quite sure where they are, so I'm going to put them round here. The NH2, CH2, CH2, NH2 has no charge, so the overall complex must still have 2 plus charge from the iron to iron. Hexaaqua iron 2 ions can react with an excess of this in a ligand substitution reaction, which shows the correct entropy for the reaction. Well, I'll show you the equation and I'll be able to explain it. So I've got 6 waters here replaced by 3 of these to make Fe, NH2, CH2, 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 3, Fe2 plus and 6 waters. In other words, 3 of these have replaced the 6 waters. And when you balance it out, I've got 1, 2, 3, 4 molecules on the left, and 1 plus 6 is 7 molecules on the right. 4 molecules make 7 molecules. If there's less molecules on the left than there are on the right, less moles on the left than there are on the right, then you're getting more molecules, more moles on the right hand side. That means you increase entropy. Entropy is positive. It's becoming more chaotic. So change in entropy is positive. The percentage of iron 2 sulfate ions in iron 2 tablets can be determined by titration. Deduce an ionic equation for the reaction of iron 2 ions with manganate 7 ions. I need to write some half equations. So let's show you that now. Iron 2 ions are Fe2 plus. they'll go to Fe3+, they're oxidized to Fe3+, and I need an electron on the right hand side because I've got 2 plus on the left, 3 plus on the right. I need to balance those up by putting a minus on the right hand side, so now there's 2 pluses overall on the left and on the right. MnO4-, how do I know that manganate is 4-? I've got to remember MnO4. I can work out that it's 1- because Mn is in oxidation state 7. It tells me that manganate 7 is in oxidation state 7. 4 2- is oxygen's in group 6, so it'll gain 2 electrons and have an oxidation state of -2. 4 - 2 is a -8, plus 7 - 8 leaves 1- left over. I need to know that I make manganese ions, Mn2 pluses, and then I've added these other things in. How have I worked this out? Well, I've got 4 O's here, and Mn2 plus hasn't got any O's, so where would those O's have gone to? Well, I can add H's and waters in, so if I need to balance O's on the right hand side and I need something to put them in, somewhere for them to go, I can add H pluses and waters, acids and water. Now, 4 O's there would mean 4 waters. To balance up the 4 O's, I've now made 8 H's. 8 H's there, 8 H pluses. Let's add up the number of charges. 1- and 8 pluses leaves 7 plus on this side, 2 plus on that side, so I need 5 electrons to make 2 plus on each side. Now I've got to add everything together, and the electrons have got to cancel. Well, they'll never cancel because I've got 5 electrons on the left on this side and 1 electron on the right on that side. So when I add everything together, it's not going to cancel. So I'm going to multiply this through by 5 to get 5 electrons on the right hand side. So I'll multiply through by 5. Now I can add everything together. MnO4- plus 8H plus 5 E- on the left, add 5 Fe2 plus, makes this. The electrons will cancel in a minute. Mn2 plus and 4H2O and 5 Fe3 plus and 5 electrons makes this, and the 5 electrons on the left and the 5 electrons on the right have cancelled. A student dissolved 1980 milligrams of iron tablets in excess of dilute sulfuric acid. The solution was titrated, and I've got a concentration 0.02 mole per decimeter cubed of potassium manganate solution, and it's given me the volume of potassium manganate solution. If I've got a volume and I've got a concentration, it wants me to work out moles, because concentration is moles divided by volume. I'm going to have to get this volume into decimeter cubed first. I've got to divide by 1,000, so to get centimeter cubed up into the next unit larger, I divide by 1,000, so that will equal 0.032. So concentration is moles divided by volume, so 0.032, the concentration equals, concentration is moles divided by volume, and the volume, as I've said, is 0.032, so 0.02, the concentration is moles divided by 0.0325 decimeter cubed. So moles, these two numbers multiplied together, 0.02 multiplied by 0.0325 is 0.00065 moles of manganate 7. Now, why did it ask me to do this equation? Well, it's asked me to make this equation and balance this equation, create this equation, so that it shows that 5 moles of iron react with 1 mole of manganate 7. So I've worked out the number of moles of potassium manganate 7. The number of moles of iron are 5 times that. So if I multiply 5, I've now got the number of moles of iron. I know the MR of the iron, so moles is mass divided by MR. I can now get mass, because I've got moles, 0.0325 is mass divided by the MR of iron. I've actually made it slightly more accurate here, 55.85, but it doesn't really matter. The mass of the iron now is 56 multiplied by 0.0325. 0.0325 multiplied by 56, or 55.85 if you do it more accurately, equals 0.182 grams of iron in the tablets. So that's how much iron in the tablets, 0.0182 grams of iron in the tablets. Yet the tablets are 1.98 grams, 1,980 milligrams. If I divide by 1,000 to get milligrams up into the next unit up grams, it comes out as 1.98 grams. So I've got 0.182 grams of iron in the tablets, and the tablets have got a mass of 1.98 grams. So what percentage is in the tablets? Well, I'd take the smaller number divided by the bigger number. This is the amount of iron in the whole tablet that must contain other impurities. 0.182 grams of iron in 1.98 grams of iron tablets, that should say. So 0.182 divided by 1.98 is the fraction, multiplied by 100%, 9.14, and I've put it to 3 significant figures because some of the other values are to 3 significant figures. I think I could have put it actually to 4 significant figures if I'd have wanted to. The other values are to 4 significant figures. State the colour change at the end point of this titration. Well, it goes pink. So it goes from colourless to pink because potassium manganate 7 is purpley pink. And so when that comes through into the solution, which is colourless, then that shows that all of the iron has reacted, and the potassium manganate 7 coming through will show as pink.